So next, I'm going to go into the actual formation of different types of sedimentary rock. So now that we know a little bit more of what we're looking for, we know about weathering, we know to look at clast size, angularity, sorting, we can start to think of how these sedimentary rocks were actually created. So each sedimentary rock can tell a story, the history of that location. Was there water there previously? Was this a very dry area? Was there mud? Were there a lot of plants? Were there shells? You can really tell a lot about the history of a location by the type of sedimentary rock that was formed. So sedimentary rock is formed in layers. So it's deposited in layers, always on the surface of the earth, flat layers. We call them beds. So the different sedimentary beds, we are referring to the different sedimentary layers. So here, for example, at the starting figure, we have a layer of silt that will be deposited during a normal river flow. So here we have a layer of silt accumulating. After that layer of silt is there, there's a flood, which will then deposit a layer of much larger grained gravel. So during that flood, a very large amount of gravel is going to be deposited. The water will recede back down after the flood, and then another layer of silt is going to accumulate. So now we have our basement rock, whatever rock was there previously. We're going to have a layer of silt, that layer of gravel from the big flood, and then another layer of silt. Over time, this will all be buried, cemented, lithified into solid rock. So we will have solid layers of rock in this same order. So siltstone, which is created from the silt, conglomerate, which we call a rock that has very rounded, large grains in it, which would have been deposited from that flood. The gravel would have turned into a layer of what we call conglomerate, and then another layer of siltstone on top. So now looking at, later in time, looking at these rock layers vertically, we can tell through time what has happened in this location. We know that it must have been under a river because there's siltstone, which means a river must have been depositing silt. There's also a conglomerate, meaning there must have been some flooding, and then there's more siltstone. So again, this area was under a flowing river. So here is another example of different beds. So the different layers of sedimentary rock here, you can very clearly see the difference in the layers as this location had different type of sediment being deposited. So when we have a section of beds or multiple beds, we call that a strata. So when we have multiple beds together, and we're looking vertically through the history of that rock profile, we call that strata. So here, for example, you can see that the geologists have determined or identified each of the individual beds here, but together this would be called a strata. And so you can see here is another example of each of our different beds here, but together we would call this a strata. So here we can see all the different rock layers that were deposited one after another. I should say the sediment layers that were deposited one after another and then formed into these sedimentary beds. So this is a really nice picture because it shows that the beds are formed completely parallel to the earth. So it is beds of sedimentary rock are always formed from that deposited sediment. So sediment is always going to be deposited flat on the surface of the earth. So in order for those beds to be formed, we know that there was many different types of sediment deposited over this entire area because we can see that the bed extends over this entire area. And the layer between two beds we call a contact. So when you hear the word contact, we are talking about the surface between two beds. So where two different sedimentary beds meet within the strata, we call that a contact. So there's a couple different types of deposition that can become very apparent because they leave behind clear markings of what happened. So often you can see ripple marks when you go to the beach. So when you see these ripples, you know that you're on the beach. This was formed by water. So this can actually help us determine what we're looking at when we're looking at sedimentary rock, and we see the same ripple patterns. So where we see rippling patterns in the surface of our sedimentary rock, we know that this rock must have formed where there was a beach, where there was wave action. And we can also tell that the ripple marks are actually going to form at a right angle to the direction of the water flow. So not only can we say, oh, there used to be water in this location, but we can determine the direction that the water was flowing based on the orientation of those ripple marks. So where we have very small ripple marks, which are just a few centimeters high, we know that this was flowing water, for example, a beach. Where we have large ripple marks, we actually call them dunes. So this would be formed from the bed of a faster moving stream or formed from the wind, for example, in a desert. That we would call dunes. So in a current, we end up with what we call cross-bedding deposition. So the layers that are formed of this sedimentary rock are created because there are dunes or ripples. So if we're thinking about dunes, which are just larger ripples, we end up seeing a curving pattern in our sedimentary bed. And that is because at the surface or at the time of deposition, let's say we have wind blowing across this sand diagram here, we're going to be moving our sand particles with the wind. So they might move a little bit from the left to the right of our diagram. As this sand accumulates at the top of this dune, it's eventually going to become too steep and the sand is going to fall to the other side. So this is the same way that sand dunes and ripples are created, either in the desert or in the water. But what we don't think about is if that if that sediment is then left alone for many thousands of years to create sedimentary rock, we're actually going to see very clear signature of this dune or of this ripple pattern. So we know that this sedimentary rock, when we see this swooshing pattern here, we know that this sediment was deposited in a current. And then from this size, we can tell if it was more of a ripple or more of a dune situation. So here is a real life example, a real photo of sediments that were deposited in a current. So here we can actually tell from the orientation of what we call this cross-bedding which way the wind was blowing while these layers were being deposited. So we can also see that the wind direction was changing over time in this location. So here's another example of how this actually happens. It can be a little hard to see in the cartoon diagrams, so I wanted to show you some actual pictures. So here our wind direction is moving from the left to the right. Here we have what we call the back side of the dune. So the sand is moving till it gets to the top of the top edge, and then it's going to slip down the the face of that dune, and then continue moving in this direction. So here we have a large dune, and you'll also see there are smaller ripples in this sand as well. So when it's a very large change, a very large slope here that we call a dune. When they're very, very small, we call them ripples. Essentially, they're the same. The only difference is the size. So along with deposition by currents, we can also have deposition by what we call turbidity. So it is not just a current moving in one direction. We actually have a current that is then causing turbidity. So this is generally underwater and where we have sediment that's being deposited on a slope. So it's not on flat ground. So what can happen is that slope might fail. So the sediment might fall or avalanche down, for example, down this canyon under this body of water. As that sediment is falling down the slope, it's going to be mixing with water. It's going to create what we call an underwater avalanche or a turbidity current. So it's going to cause a lot of motion of that sediment of various sizes with the water. So what happens here is we create what is called a graded bed. So as this water slows, so this might be something that happens very quickly. We have the slope failure. All of this debris, this sediment flows down the hill, mixes with the water. There's a lot of turbidity. The water would become very dusty. We wouldn't be able to see very much. As the water slows and everything calms down, the sediments are going to settle out. So these sediments are now floating in the water, mixed in with the water. As the water slows down, the sediments are going to settle to the bottom. What happens is the heaviest and largest sediments settle out first. So if we have all these sediments mixed in with water, and then the water starts to calm down, the heaviest bits of rock are going to fall to the surface much faster. The very, very light suspended particles are going to take their time settling out. So we end up with what we call a graded bed. So that means that we have layering within the rock layer. So we have the largest grain sizes at the bottom, because as this water starts to slow down, the bigger pieces are going to fall to the bottom first. And then as the water continues to slow, you're going to have the more medium-sized pieces falling to the bottom. And then as it fully slows, you'll have the smallest sand or silt-sized pieces. And then finally, all of the material that was suspended, making the water look dusty or muddy, is going to fall. So you end up with what we call a graded bed, where we have the largest grains at the bottom and the smallest grains at the top, and it's very nicely ordered. And this is because these sediments were all mixed together within water, and then as they settled to the bottom, they settled out by size and by weight. So there's a few other factors with sedimentary rocks that can tell us a lot about the history of that rock. So there are certain markings on the rock that tell us a lot about the rock formation. So we can see markings on the surface of a rock, a surface of a layer of rock. That is going to tell us what the surface of that layer looked like before it was formed. So there can be mud cracks, scour marks, there can be fossils. So any of these things add more clues to help us discover the history of that rock layer. So for example, here we have mud cracks that could then be formed into a layer of sedimentary rock that looks something like this. So this is telling us that this location used to be very muddy. So there used to be water, because there is the signature of mud cracks on this rock layer. So there are a couple of different ways to think about how the rock was formed. And one of the main ways to think about is, how was the sediment deposited? So was this deposited in a terrestrial environment? Streams, sand dunes, rivers, lakes, glacially moved by glacial ice? Or is this a marine deposition? So deltas, beaches, shallow marine versus deep water marine. There's many different ways to think about how was the sediment deposited before it became this sedimentary rock layer. That can again give us more clues into how the rock was formed and why. So some things to think about when you're trying to determine the depositional environment would be the sorting. Is it is it well sorted or poorly sorted? Are your clasts angular versus rounded? What are the clast sizes? Are you looking at really large clasts versus very small ones? Each of these factors are going to give us more and more information about how and where the rock was formed. So for example, here we have what we call a conglomerate. This has more rounded clasts. Here actually is a shell. It looks like pebbles. It's a solid rock, but it's made up of all of these smaller rounded pebbles. Whereas here, this is a breccia, and it is made up of much more angular clasts. So this is very poorly sorted. We have some large clasts, some small ones, and they're very angular. So looking at this, we would think that this sediment would have been formed in a terrestrial environment because the grains are not very weathered. They're rather angular. And we would think there was not a lot of transportation before this was deposited. So these sediments did not travel far from their original location before this rock was formed. Whereas this conglomerate, I would think it is a marine environment because there is a presence of this shell. I would also think that the sediments traveled quite far before they got to the location where this rock was formed because many of the sediments are very, very rounded. So it's possible that these sediments came flowing down a river and then were deposited, say, in a delta at the end of the delta where the river meets the ocean. So there are all sorts of clues within the sedimentary rock samples, the sedimentary rock layers or beds, and then the whole strata itself to tell us the history of that location. So here are some examples of where we would see deposition and how all of these different locations can work together to create different types of sedimentary rock. So here are some examples of terrestrial sedimentary environments. So a mountain stream, some dunes. This is what we call an alluvial fan. So this is where every time it rains or there's snow melt from the top of these mountains here, these rivers are going to form. So all of the sediment, all of the weathering that happens from that river is going to flow down the side of the mountain. It's going to hit the base of the mountain, and then when it hits the base of the mountain, the water is going to slow down because it's no longer flowing downhill. As it slows down, all of those sediments that it was carrying are going to fall out or sink to the bottom. So we end up with this deposition in a fan shape, which we call an alluvial fan. So this is going to be replenished every time there is water flowing down this stream. So I personally would not have built a road right here because it's just going to continually be covered in this deposit. Some marine sedimentary environments. We have a delta. So where the river meets the ocean, similarly to the alluvial fan, when the river meets the ocean, that water is going to slow down. It was a flowing river, it meets the slow-moving ocean. All of that sediment is going to settle out to the bottom. So we have a delta around the end of the river. Here's a beach, here is a cliffside here. Many different sedimentary environments where these sedimentary rocks could potentially be formed, either marine or terrestrial. But looking at the samples, you should be able to tell, or hopefully you will be able to tell a lot about the history of how and why and where that rock was formed.